Alright, time for another DraftPhysics.com, debatephysics.com also, video presentation. So on the website, debatephysics.com, you will find a bunch of 5-minute videos just illustrating the different little arguments that can be made about different experiments and the fact that momentum really does have to be conserved. And there's no logic to not conserving momentum, and kinetic energy is just a fable. It's just made up, and it doesn't serve any purpose. And frankly, it doesn't cure any diseases, it doesn't fix any part of physics, and it just creates a bunch of wrong answers, frankly. And all of the accelerator physics is based on those wrong answers. So the whole reason neutrinos exist is because they use mv squared in their calculations. Anyway, so, do you really believe it takes 100 times the energy to spin a motor 10 times as fast? Do you think that is true? That if I go 10 miles an hour, I'll use 1 gallon of gasoline. If I go 100 miles an hour, I will use 100 gallons of gasoline. Do you believe that is true? Because that's overtly what their physics demands the truth to be. Do you believe that? And if you are at least concede that, oh yeah, that's doubtable, I could doubt that. Yeah, that doesn't sound quite right. And say, I want to see more evidence. Then yes, say that. I want to see better. I want to see not only more evidence, I want to see better evidence. I want to see, they've had 300 years to do these simple collision experiments and we don't have them. So let me just illustrate one of these simple experiments that we don't have. In 300 years, they couldn't do this scientifically. They couldn't scientifically show us it to be true. So let's just draw that one real quick because it illustrates the other point some commenter's going to bring up. That somehow we have to believe that they've already proven it or some other kind of crap. So you have this simple idea. You got a Newton's cradle. You have a 3 mass and you have a 1 mass. Alright, so you swing the 1 mass out. Okay, you're going to collide it into the 3 mass. Alright, and so let's just say for the sake of argument, this is 100 momentum. Okay, the mv equals 100. Alright. Let it go down and hit the 3 mass. They say, okay, that the 3 mass swings out here, okay, with 150 momentums. All right, that it got half the original velocity. All right, and that this will bounce back, okay, with 50. All right, so you got 200 total back. If you think of it as momentum being any movement is momentum. Doesn't matter which direction it is, it's motion in the universe. So they're arguing that you put 100 into the system pushes back, okay, like a spring, it pushes back with 200. And then the 200 comes back in, so this, you actually believe this is what happens. Okay, it doesn't seem doubtable or anything like that to you. So you have a car crash now, where you have one with 50 momentum and you have one with 150 momentum. All right, and now they're going to crash into each other. All right, and in that car crash, only 100 is going to pop back out. So you have 200 in and you get 100 out. So you destroy the momentum. So you create free momentum, then you destroy the momentum. Then you create free momentum and then you destroy the momentum. You think that's physically possible. In spite of Professor Lewin saying nature can deal with kinetic energy one way or the other, but nature can't finagle momentum. Instead of a lot of emphatic statements by a lot of physicists saying momentum has to be conserved in collisions. That closed systems always have to have the same momentum in them. You can't make the momentum disappear and you can't make more momentum pop out. That momentum has to be conserved. Okay, it can't magically switch to another dimension. It can't fly into the 7th dimension. It can't do any of that stuff. It has to be here somewhere. Well, in this experiment, it doesn't have to be here somewhere. Okay, it's gone and it's freely, obviously created. All right, so that's what this is all based on. Is this idea that somehow a 1 mass can go in and free momentum can continue in the same direction. and that you can have even more momentum going the opposite way, that you gain all this extra. And so this has to do with these card experiments, and they're all done with springs. So you do have to put a spring in here just to play with the idea. Obviously the Newton cradle doesn't need a spring because it's very efficient in transferring the energy, but somehow the other experiments need a spring or it don't work. So anyway, so that's what's being argued, and you're telling me I'm unreasonable and I'm some sort of major asshole because I say this is inconsistent with everything I've ever understood about anything about physics, is that you have to conserve what was I understood to be energy, which is obviously something's mass and velocity, and that you can't just make it go away. When the hammer hits the ground, I drop a hammer, it hits the ground, all the little shit that flies up and gets moved by the hammer, when I add all that shit up, okay, and the little bit of heat and other stuff that might fly out of that collision, it has to add up to the momentum the hammer had. It can't add up to something else. You're saying that's an unreasonable statement for somebody to make. I'm saying no, it isn't unreasonable. It's perfectly reasonable. So this experiment is supposed to be done by physicist Michael. Okay, so 2 months ago he said he would do it. Two and a half, I don't know. Back before Christmas. So far, no, we don't see it. So we have no clinical, this experiment has never been done under scientific clinical circumstances. At least there's no reference to it ever being done by a physicist. So we don't have a paper on it, we don't have a video, we don't have a 1950s video, we don't have anything demonstrating that this actually happens. And this is the cleanest way you can do the experiment possible, really. I mean, Newton's cradle is so clean. I mean, you have so little, nothing can really fool you here. There's no 3-card Monte. There's no wheel track. There's no bunch of little wheels on a cart, okay? Where you can, obviously hide momentum. Something going fast that has lots of wheels can hit something that's heavy, and its wheels will turn much slower. So even though they have the same number and the same size wheels, the thing it hits will actually have more linear momentum, I mean velocity, because although the angular momentum is not going to be the same. The thing going in, the light cart going fast, I should actually just draw that, right? The light car going fast, okay, stores momentum in its angular rotation of the wheels. All these little arrows going around is not linear momentum. It's the mass of the wheels spinning. And so when the cart's going fast, there's a high amount, okay, of angular momentum. If this goes half the speed, it means half the angular momentum isn't in these wheels. These wheels have 1/2 less, okay, 1/2 less of the angular momentum in the wheels, and therefore it has to be in the linear motion. So you could actually have the circumstance where you crash a cart that's lighter, okay, that has a certain momentum number, okay, and you'll actually get more momentum here because there's less momentum in the angular rotation of the wheels. It's just an absolute fact that that's a problem because energy is hidden now. All right. Just a fact. Okay, sorry, don't want to bludgeon you with facts, but it just happens to be a fact. All right. So that's sort of the context of some of this. So this is the bullet argument first, so we'll do that first. All right, let's say we have a gun mass 5 kilograms, so we could say a pound, okay? A bullet mass 0.007. Why don't you just do 1,000 to 1, all right? Why not just make it simple, right? Why use 5 and 7? Why don't you just use 5 and 5? All right, so we'll just make it 1,000 times difference in the masses. The gun weighs 1,000 times more than the bullet. Okay, and bullet velocity, who cares? But yes, 300 meters per second. Assuming equal momentums. You don't have to assume it, you can actually know it as a fact. Okay, and science says that it's a fact, frankly. So who's kidding who? The ballistic pendulum says it's a fact. The momentum is conserved. When you fire the gun, there will be, as Newton states, an equal and opposite reaction. And of course, Newton believed in momentum. He didn't believe in mv squared. So when Newton wrote the third law, He was writing it about momentum. The third law doesn't apply to anything else. It applies to momentum. All right, the gun will have a velocity of 4.2 meters per second. Do you think the gun and the bullet would make the same damage? Now, that's the key word, right? My simple argument is they will move the same amount of mass in the universe. So the 8-pound bowling ball going 16 miles an hour will move, okay, will give pins the same total momentum that the other ball gave. It won't make any difference to the momentum of the pins, but how fast individual pins are going will be different. So you'll get a different number for how many pins you hit in terms of some pins will be going faster and some pins will be going slower. So if you used up all the momentum, say hitting 12 pins or 15 pins or whatever number would use up all the momentum, you would just argue that yes, the lighter ball will give the first pin more energy than the 16-pound ball. The 16-pound ball can only give its velocity. So the 16-pound ball is only going 8. So when it hits a pin, it can't make the pin go 17. It can't make the pin go 25. The pins don't have springs on them. So it's likely to just make the pin fly away at 8. Okay, 8 times its mass. But the ball going 16 miles per hour that weighs less, well, yeah, it can make the pin go 16 miles an hour. But the point is when it does that times the mass, this is going to be a much higher number. So we could say it could be a 35 is the momentum. Okay, and this one was only 17. The fact is this 35 comes out of this thing's momentum. So now it has a lot less momentum. It's losing momentum quicker. So the fast thing loses its momentum very rapidly. The heavy, slow thing loses its momentum very slowly. So obviously that would have to be when you're talking about damaging a surface. Okay, I've brought this up before, but there's just, it's an absolute fact that you can use the same amount of momentum and hit a board, for example, a piece of wood, and a big slow thing will bend the board and then the board will bounce back, no problem. But if I shoot a small light thing that's going fast, I'll crack the board, break it in half. Okay, so that's karate. They call that karate. Okay, you can do this karate chopping. Okay, and it allows you to break a board, not only because you're concentrating the energy, but because you're using quicker energy. And the quick energy means the fibers aren't allowed to bend. It's beyond their bendable ability because you're putting all the energy in very quickly. You're forcing it to move a lot in a small amount of time. And some things can't move a lot of distance in a small amount of time. They can only move a lot of distance slowly. If you try to make them go fast, they dent, they do all kinds of things. And so it's sort of the argument, okay, you're going to make it a satirical, rhetorical question. So I'll ask you the rhetorical question. Does a pointed arrow, okay, or an arrow with a ball at the end, does the pointed arrow, they have exactly the same momentum, exactly the same velocity. Because the pointed arrow is going to do a hell of a lot more damage, does it mean the pointed arrow has more energy? Mocking you. I'm just mocking you with the question. Are you that stupid to think so? You can't understand that if the application of the energy matters, how you apply energy will change what the result of the energy application will be. And that if you apply energy very quickly, you can shatter something. And you apply the energy very slowly, no, the thing just bends and says, okay, fine, whatever. So I'm sorry you're too stupid to understand. It's even like the application of heat. I could apply heat to you, 500 watts. I could apply it over 2 minutes and your hand just gets warm and says, thank you very much. I could apply it over 2 milliseconds and I burn a hole through you, okay? The difference between a light bulb and a laser beam. Do you think that both of them are using exactly the same wattage? Let's just say 5 watts. They're converting at 98% efficiency. We'll just make up a number. They're both converting the energy into photons at exactly the same efficiency. So it's the same amount of little particles moving, but obviously the distribution of the energy makes a huge difference. So yes, of course it makes a difference how you apply the energy, both in terms of how much surface area you hit and how quickly you force it to absorb the energy. Those two things matter. But the fact is, in the end, when you count all of the molecules moved, they are going to move the same amount of matter in the universe. The momentum will be conserved, as physicists say. You pile of fucking pus. Okay. So he says, assuming equal momentums, the gun will have a velocity of 4.2 meters per second. Do you think the gun and the bullet would make the same damage even if they had the same shape? Is that what you really think? Yes, I really think. Okay, the fact is that even if you made them the same shape, you have to understand you're still distributing the energy. It's the difference between you could have a long poker or you could have the bullet, right? I can make the end of my pointer the same exact shape as the bullet. And I could poke somebody slowly or I could poke somebody quickly with the little tiny bullet. And again, the argument is that yes, those two things will do different kinds of damage. Just a fact, okay? Because one of them is going to apply all of the energy quickly. It's even going to cause, the bullet is going to get hot because it's doing it so quickly. It's going to dissipate a lot more heat. So in fact, the poker will probably go further into the person because I won't dissipate the energy in cauterizing a bunch of blood. I won't be boiling blood and doing all this other stuff the bullet's going to be doing. So in truth, I could probably get more penetration out of a very long bullet moving slowly than a very fast bullet moving quickly in terms of throwing it. You know, throwing a spear at 10 miles an hour versus the bullet at 300 miles an hour. The fact is the heavy spear might actually do more penetration. So yes, that's what I think, you fucking piece of pus. All right. Then he says, when are you going to respond to Dispar Lab? I've already pointed out how I'm not going to respond to liars, and these people are pathetic liars. They leave up videos where they made egregious mistakes in the video, they didn't measure correctly, and the results are absolute pseudoscience crap. It might as be, it's worse than a flat earth video, it's fake science. Okay, and they're proud to leave their fake science videos up. All right, and so that I'm not accepting. Besides all the ragged nonsense in the comments, I have no reason to accept that kind of rhetoric. I don't have any reason to accept all this invasion of my personal life. I have no reason to respect these people as making respectable arguments because they can't monitor their clan, their group, their little cult, and force it to behave in any kind of reasonable, non-lying manner. So they just constantly lie about what I've said and what I've done in my videos. They don't play the actual arguments in my videos, at least not in context. I have absolutely no obligation to interact with these weasels and assholes. So that's why I'm looking for other people to interact with. Okay, and that's what I'll continue to do. These are the last people on earth that deserve argument because they can't make a reasoned, on the subject argument. All they're interested in is propaganda and overt lies. Again, their videos are complete deceptions. They leave up videos titled proof when it's absolute bullshit. And then when they make these fucking calculation mistakes like this bar made knocking his little carton over, they don't redo the experiment doing the right fucking math. Figuring out that, yes, the arc of the two things, one of them slowed down more, I have to redo the experiment fairly. So he didn't do the experiment the fair way, which would have produced results completely consistent with what I'm arguing, would have proven me right. So when he did it wrong, he leaves the wrong up. He doesn't redo it right, because that will prove me right. All right, and that's how dishonest these scumbags are. So yes, I'm not interested. All right, so yes, I did go look. He made a video 3 days ago bringing up the Professor Lewin bullshit again. Okay, and obviously that's the pendulum argument that I just displayed for you. So do you think you can make free momentum? Okay, just tell me that yes, you think that happens. And I'm just going to say to you, well, how come it never happens in a car crash? How come it never happens anywhere else on this planet except with these little rickety cart experiments, these little rickety air track experiments? How come it doesn't happen any fucking place else? How come, fuckhead? All right, so then he puts this other, I mean, he calls himself Some Fool Online. And you're just saying, Jesus fucking Christ, he's just making himself so blockable. Because, yeah, you are a fool. You're a dupe and a moron. I mean, why don't you know, make a video, have the guts. You know, argue your argument. You have some sort of argument that I've been unreasonable, that what I just stated in this video wasn't true, that there isn't such a thing called karate, where they demonstrate that the application of energy means a lot, that how you apply the energy is almost as important as having the energy. You fucking piece of shit. Anyway, okay. Are you not worried that your theoretical physicist, so that's what he's calling me, has said things like, and each one of these mistakes I've made I have owned up to, and some of them are just trivial, you know, rhetoric mistakes where you just say, and the electron, and you meant to say the proton. You know, some of them are just stupid mistakes. And the one video where I made an egregious mistake in the sense that it just was stuck in my head for some dumb reason, that twice the height was twice the velocity. I took it down in 6 hours. So in 6 hours, I knew I'd made the mistake. I took it down before anybody else said I made a mistake. I thought about it. I lied down. I woke up. I said, that doesn't seem right. I made a mistake. And I took the video down. So what? You're going to harp on me because I've made a few mistakes in over thousands of videos? Thousands of videos. A couple of them have a couple of trivial mistakes. And this is the game you're going to play. You motherfucker. Alright. Let's see. Stupid things like twice the distance means twice the velocity in free fall. Yeah, it was a mistake. I owned up to it, and you know, what else can I do? I took the video down and said, yeah, that was really stupid. That's it for you, right? So no one's allowed to make a mistake. I mean, Einstein made a huge mistake. I mean, he put a constant in, and then he took the constant out, and then they said, oh, wait a minute, we got to put it back in again. All right, the length of the pendulum doesn't affect its period with 100% confidence. Whatever. Talking about the length versus the mass, yes, I can see how somebody can make the mistake of thinking, okay, wait, you can change the mass of a pendulum, but you can't change, because everything moves at the same speed, but you can't change the length of the pendulum. Oh, okay. So all I did was invert two things, not a big deal. Are things like 9.8 meters of velocity. Of course, a perfectly sensible thing to say, okay? It's obviously meters per second of velocity, so you're just basically shortening the statement and say, look, it's 9.8 meters of gain in your velocity. Now, I guess I could say it's 4.9 actual meters of distance that you'll gain per second, and that's all you're going to gain, is just that 4.9 meters of extra new distance. But whatever. So he thinks this is a big deal. 9.8 meters instead of me saying per second, okay, of velocity, when they constantly say per second per second. So it's not silly and stupid for them to say per second per second. And the bigger crime isn't saying per second, because that's frankly a little bit harmless, because the number of per seconds could be any number. It's when they say per second means velocity squared or acceleration squared. That's the silly part. Because something can happen 5 seconds and something could happen 10 seconds, why would I say squared seconds? Alright, it doesn't bother you that he claims it's all just momentum, clearly, when momentum alone obviously cannot predict the results of collision. So where's the obvious part? Show me a single car crash where the momentum doesn't predict the outcome. Show me bumper cars. Show me some example in the real world with something real where your theory is right. Show me the small wrecking ball doing more work. Show me the spacecraft that is in fact navigates in space based on the fact that throwing light things works better. Show me any evidence that kinetic energy moves spacecraft. or that he is not even interested in making such predictions. Well, I make them constantly in the video. I'm making overt assertions. My prediction is momentum can never be created or destroyed, and that you can only analyze a situation badly to ever see that happen. If you're seeing that happen, you're seeing something that didn't physically, there's a hidden trick somewhere. There's some sort of defect in your experiment. Your experiment isn't level, or you've measured wrong, or you're not accounting for the angular momentum. You're missing some little feature. Okay. It does not bother you that he is unable to understand the unit of acceleration. So what the fuck is there to understand? It's a change in your velocity. It's nothing but adding velocity or subtracting velocity. Velocity is a something has, and you're just saying I'm going to take some away or I'm going to add some. There's no unit of acceleration, whatever the fuck you're talking about. All right, if you feel fine about the implication that all the science teachers giving demonstrations of elastic collisions, etc., just lie about the parameters, I'm saying that clearly their only purpose is to do demonstrations, and that can be illustrated. Okay, we can play some Professor Lewin video. He's got a $10,000 air track, okay, a precision instrument, and what do? They do little show videos. Do they take a few hours or even a few days and compile a whole bunch of experiments and show all the different nuances and put springs at the end, see how long something travels? Do they do any of that shit? Nothing. They're not using it as an experimental device. They're using it as a display. They're doing it to propagandize, quite obviously. Quite obviously, they know what the book says the answer is supposed to be, and they just force the device to produce the answer. Duh. I mean, it's so obvious. Come on, guys. Seriously. Come on, guys. So he's talking, he's defending an experiment where there's no logic defending the weight of the carts. Okay, you can just look at them and there's no way you could rationally say that cart is twice as heavy as that cart. Just no way to do it. All right. And on top of that, there's this ugly, stinking blob of clay on the goddamn cart. I mean, shit. Just proving it's an engineered experiment. All right. So, yeah, what to do with this asshole? Well, I'm going to delete this other comment because it's just a lie, frankly. It's just a lie to pretend the mistakes I have made are at all significant and that I haven't owned up to them. So, fuck you. That's just bullshit. All right, maybe I'll just leave this one and post a link to this video after it. All right, so let's do the this is the disbarred channel. So this is what he has done. It's the Professor Lewin. Did Professor Lewin manipulate the weights of the cart? So he's not going to prove anything on the weight subject at all. And all he's going to say is, well, look at these velocity numbers. And clearly, if you're going to change the weight of the carts, the simple thing for anyone to understand is when he does these experiments, they can fuck with the weights. That's what obviously the blobs of clay are there for. And all they have to do is change the card a little tiny bit. So, the whole way the cart is measuring time is, not because the timing gate doesn't work, but the cart has a little card on it, okay? It's just a little card sticking on it. And so, I mean, if you're willing to alter the weights of the carts, why wouldn't you be willing to alter something more? And so all they have to do is alter the size of the card. They just make the card a little smaller or make the card a little bigger, and now it's going to read a higher or slower velocity. So, and all of that's just, you just shave a little bit off the card. It's no big deal. It doesn't take any work at all. That change things by 10 or 15 or 20%. And that's all you need. Fuck up the weight of the carts a little, fuck up the card a little bit, and you can get any numbers you want to come out on that screen. And that's just a fact. And so playing a game that somehow, well, the card, you couldn't, and even if, let's say the two weighed the same, which I didn't argue. I argued that this one is just more than half the weight. Okay, so one is supposed to be half the weight of the other cart. All right, and so I just argued that it's more than half. Okay, because it has blobs of, it has two blobs of clay on it. We can't see the other side, but they always put one on one side to keep the cart balanced. And this thing's missing those two. And then it's got one weight on it, and this one's got one weight on it, so this one's missing two weights. You know, so you can just keep adding up all the stuff. The carts can't be the same mass. It's just logically impossible to believe they're the same, you know, 2-to-1 relationship. So anyway, so the numbers come out where, yes, it is exactly 2/3 by the clock reading. Okay, so this cart leaves with 2/3 the velocity, and this one has 1/3. All right, and so what does that mean, though? That means from their collision point. So this is just, look, I didn't analyze this hard, but I mean just superficially measuring on my computer screen. Guess what? It doesn't quite work, okay? Because when they move away, this one doesn't move away, okay, at 2 units. You know, this one's supposed to be 2 units of distance per every 1 unit of distance here. And it doesn't come out. It's 10, 15% off. So the fact is those numbers he's using as velocities may not be right. Now, the video isn't good enough quality to do real frame rates on, but the fact is, okay, is that we should have video good enough to do that with. There should be really good video of this experiment, not shitty video. And if you can't own up to that fact, that in 300 years you're going to make an assertion that you can make free momentum, you should back up the assertion that you can make free momentum. I mean, free momentum. Free, you know, don't you, I mean, do you people really believe that it's free energy? I mean, free momentum is free energy. So if you're going to defend the notion that I can just bang something into something and I can get more momentum out for free, then you have to explain why we don't completely capitalize on this easy way to make any energy work better by just taking our energy and banging it into something heavier, and we can make more momentum. So all we have to do is like bang water into mercury in a stream or something, and somehow we'll make more energy to spin the wheel. You know, or just make the wheel heavier and we can make more energy. Make the paddle wheel heavier and heavier, and I can make more and more free momentum out of the water. I mean, the consequences of this nonsense. Gears become nonsense. Hydraulics becomes nonsense. Free momentum is not possible. All right. So yeah, I'm not playing his fucking bullshit video. I'm sure the other bullshit video is still up here, right? So let's go to, you know, whatever it was called, testing something, you know, a simple kinetic energy experiment. Yeah, that's it, with a stupid card. So he still got it up. He doesn't say in parentheses here, absolute bullshit, because I didn't measure right. So he doesn't qualify that this is a lie and this is nonsense and this is propaganda and it's bullshit. He doesn't qualify it at all. He just leaves it up as if it's a kinetic energy experiment of some validity, when it's fundamentally flawed. I mean, fundamentally flawed in the reasoning. He is not. The velocities he's measuring are not the velocities that happen at impact. So it's a complete lie video. And it's still up. So again, why play with people that are just dishonest? He's basically doing what Professor Lewin's doing. I'll just make a fake video. I'll leave it up as if it proves something, when it's clearly got catastrophic flaws in it. So fuck that. Fuck you. So let's see him analyze this Professor Lewin video. So this is in the same fucking video that has the other, you know, the original I made free momentum. Okay, that's in here, right? Gets to the air cart right over here. Okay. So, you know, where he makes free momentum on his air track. Now, in this experiment, he wasn't supposed to have, he was supposed to be doing an inelastic collision, and instead he did an elastic collision, okay, by accident. You know, so it turned out inelastic. I mean, yeah, it turned out elastic when he was trying to do inelastic. So the two carts were supposed to stick to each other, and they didn't. Okay, and what does he got as a result? You can see there right on the screen that the incoming velocity is clearly more than twice the outgoing velocity. So the heavier mass is leaving with a lot less, okay, than half the velocity. 50 units or whatever you want to say. So 25 plus 11, no, it should be it should be 222 and it's 275. So it's 50. Yeah. 53. All right. So clearly way below half. And the other 53 is left in the little cart still moving. So the little cart just keeps going a little bit. And the heavy cart went off with less than half the velocity. So in an elastic collision, not intended to be elastic, without a spring, that's what happened. Okay, it didn't bounce back because there's no spring. All right, partially for the reason there's no spring, you could argue. And that's the whole question here, is how much do springs screw up the transfers of momentum between uneven masses? And they exaggerate what happens with uneven masses. So a spring has a consequence. So I guess I could do that next. But we'll just play with this video first, just so you can see it and see how when he's not trying to produce the result, that is when he hasn't engineered the experiment to come out the way the book says, and he accidentally does the same exact experiment. So let's understand, it's the same exact experiment. He doesn't get the right result.
2, 8, 8. 1, 3, 8, 2, 8, 8. 1, 3, 8.
Oh, somehow we're further. I went back. All right, so we have to go to where it bounced. What the hell happened? All right, so it should be right in here somewhere.
Twice as long because the speed goes down by a factor of 2. So when I multiply...
That's the first experiment. Okay, where he's just connecting. This is the 5-ton, 10-ton. So we might as well do this just for the fun of it, right? So he's going to take a cart, and he's basically going to turn a cart that, you know, weighs 5, and he's going to bang it into another cart that weighs 5, and he's going to end up with a 10. And you'll see the momentum is 100% conserved. I mean, just a tiny bit lost. Tiny, tiny bit. 1%. You know. And the fact is, but half the kinetic energy was lost. So he'll say that, I think. Does he say that later in the lecture? I don't think he has much time, so he can't say it later in the lecture. It must be in the next lecture. But he loses half the kinetic energy. And you can see how graceful the contact is. You can see that there's really no way you could say half the energy of the motion, half its energy disappeared into some kind of heat or vibrations or some sort of nonsense, but you didn't have to use any momentum. So that is, if you could just break a piece off, right? If we said all the kinetic energy that was going to get used was going to be in a piece that flies off, I think you could understand that you'd have to explain how you conserved all the momentum, but you broke that piece off and shot it into space. You can't give something momentum without giving it away. If I can have $10 and I can bang into something and I can give it momentum, well, I have to lose my money to do it. I have to give them the energy. They can't just have it and I get to keep it. I can't give them $5 and I get to keep the $5. That can't happen in this frickin' universe. And I shouldn't have to say that over and over again. All right, well, let's play this. What the hell?
I would like to get that number back. Here I get the time for this car. The first one to come in gives me a certain time. When they continue to get...
So these are perfectly consistent with momentum. Let's just understand. So he bangs a 1 car into a 1 car, gets the consistent half the velocity, and he bangs a 1 car into a 3 car and gets perfectly consistent with conservation of momentum.
The speed is 3 times lower that I would like to do now. So we have to get the noise back home.
So again, very...
Are they 0?
I mean, this air track is really nice. It has 2 air compressors, really nice. Do they do any experiments with it? No. They just do this presentation shit. So they don't use it as an experimental device. They use it as a display device.
Okay, you ready? This one is going to plow into this one.
Right, and you're going to lose 1/2 the kinetic energy. So something is important, 500 joules. Let's just say it's going in with 100 joules of energy. It's going to lose half the joules of energy. Where'd it go? Would be the simple question. And yet I'm going to get all the momentum back, though. So all the momentum will be conserved, but I'll lose half the energy, whatever the fuck that word means to you people. half the energy is gone, disappeared, isn't there anymore, but all of the momentum is still there. And that makes sense to you fucks. You fuckers actually sit there and say, yeah, that makes sense to me. That, yes, I conserve all the momentum, so all of the movement of matter is still moving. The same amount of mass is moving the same total amount of velocity. So all the atoms are still doing, I have more atoms moving a slower speed. It's perfectly conserved, but I lost half the energy. Oh, come on.
They merge and they continue, and then you'll see the time t prime here. There we go. Ready?
Lucy, give me the ball back.
Good Quaker Oats.
Disappointing that he has so many commercials on these videos.
All right. What do we see?
So 138 to 88, so just a little bit off of what it should have been, right? I mean, you're talking 38 is a little bit short of 44. Okay, so 6. So 6 out of 200. So it's a pretty small percentage. 3%. The most. No, it's 0.3%.
138 2 8 8. 138 2 8 8. 138.
All right, you'll get to the good part. So
2 8.
Any minute now.
Divide this by 2 is 0.144. That is, the difference is only 6, and that is only
2%.
4% off.
2%.
That's completely within my prediction that each time could be off by 2.5%.
2%.
Now I will have
My
a
poor.
car
Anyway,
which is twice the mass.
so here you go. So he has all these cards. So let's understand, he has the carts all set up, right? He has a cart for each experiment. They don't, use the same ones over again too often. It's always some sort of bullshit. And that you can see in the other experiment. The carts are engineered for the very specific experiment. Part of the game. Because they've been engineered for the experiment. It's never as simple as, well, here's a 1-mass cart, here's a 2-mass cart. Now, you will see here that this cart looks completely different than the cart he used in the previous experiment. They're supposed to be twice the mass. So clearly we're not, this is the same 1-hour lecture. So why isn't he using the same carts and just changing the Velcro strips,
This is once the mass. I will set them again to 0. And now we get 1 onto double the mass. You ready?
All right, so what's going to happen here is a mistake. So it's going to bounce instead of stick. And when it bounces, what's going to happen? Well, you're not going to get 2/3 the velocity going out. That's for sure.
There we go. Oh.
Yeah, so there's your numbers, right? So there's no 2/3 the velocity still going that way. It's less than half the velocity going that way in that cart. And the other thing, instead of going the other way, we don't see its measurement, but the little cart didn't, keep much velocity, but it still has velocity. You can see the distance between the two carts. I mean, obviously the little cart's going a lot slower than the big cart is. But there's still some energy there, 50. So like 1/4 or 1/6 of the momentum is still in the little cart, and the other cart has the substance of the momentum, but it's clearly in the form of less than half the velocity, just the way it's supposed to be. So the momentum is conserved again, and kinetic energy is destroyed again. Okay, so but how are you going to make the argument? I mean, it's a completely different outcome. Clearly, it didn't go flying off with 182 or something, right? Didn't have some way lower number than that 275. It has to have a number. Again, above 222 means it's going much slower than half. Below 222 means it's going faster. So it needs to go 100 times. 100 needs to be subtracted from that number to be 2/3. For it to be 2/3 of velocity, that number needed to be 175. And it's not, clearly. So shove that up your butts. And, you know, I mean, you just keep pretending that you want science that looks as bad as this. You want blobs of clay on your science. You want your science to be this presentation crap. You know, this is what you want from science. You don't want real hard evidence. You want this mushy crap. And again, the pendulum is the perfect way to test it. If you can make free momentum using a Newton's cradle, I'd say that's one hell of a feat. So do that. All right. Despard says he did it, but obviously it wasn't a proper Newton's cradle. The objects weren't round. You know, lots of problems. All right. So anyway, so I think that's enough. Yeah, I don't have any obligation to, like I said, his video is ignoring all these other little details that are frankly just as fudgeable as anything else, and I just don't have any obligation to be, you know, Columbo and have to keep doing this I gotcha crap with any of your silly assertions, your crazy and stupid and weak alibis. You know, why there's clay on the damn cart. You know, why this experiment came out so different than the first experiment. Why is it so different? You know. Why? Oh, the Velcro stole all the energy. Okay, you could make that argument. But when it sticks, the Velcro doesn't steal the energy. The momentum isn't stolen. You know, so, yeah, it's just bullshit. So, yeah, fuck you. That'll be my statement. My counter argument to this rubbish talk that they have established some sort of indestructible proof and we all must believe, even though spaceships don't do it, Newton's cradles don't do it, wrecking balls don't do it, bowling balls don't do it, car crashes don't do it. There's just no evidence of this crap. Again, do you believe that if I go 10 miles an hour, I use, let's just say, a gallon of gas? And then if I go 20 or 50 miles an hour, I'll use 25 gallons of gas. Do you believe that's the truth? Because that's what their physics demands to be true. You want to spin a motor is a better example. You really think that, you know, I spin a bicycle wheel, you know, 1 revolution a second. And then I spin it 5 revolutions a second, and I have to do 25 times the energy. I have to put 25 times the energy in to make it spin 5 times as fast. When I think, you know, 5 times the energy will be plenty. That's all I need. Because it's just momentum. There isn't anything else. There's just the momentum. There's just masses moving velocities. And when you add up all the masses moving a velocity, it always has to be conserved. 1,000 atoms moving 1 mile an hour is the same amount of movement in the universe as 1 atom moving 1,000 miles an hour. Same amount of energy. Same amount of capacity to do work. All you have to do is distribute it appropriately, and you can get work out of it. Distribute it in some other way and you won't get work out of it. Again, it's like drying your hair. If I took all the wattage, let's say you're using a blow dryer and you're drying your hair. If I took all the wattage that you use to dry your hair and I cut the amount of time in half or in 1/4, so now all that watts goes into your hair quickly. Your hair melts and maybe even catches on fire. So clearly the same amount of energy just distributed over a different length of time makes a huge difference in outcomes. But it doesn't have anything to do with how much energy you put in. You could rub a stick for 3 hours at a speed. Okay, and you're putting in 5,000 watts of energy, whatever, some number. And then I could do it really fast in a shorter amount of time and I can start a fire. Huge difference. Same thing. I can have a round piece of glass that isn't shaped in any particular way, right? And the piece of glass, I hold it up and it doesn't make a fire. But I bend the glass a little, I move where the mass is in the glass a little tiny bit. The same energy goes into the glass and yet it makes a fire because I've distributed the energy differently, and that's it. But there's not more energy. Okay, yeah, that's enough. I mean, this is such trivial. I mean, this should be something that's really nailed down in grammar school. And it was for me, frankly, so at least they got that part right. I mean, they talked a lot of nonsense about wavetons, you know, photons bouncing all over the place. Oh, not bounce, waving all over the place. Silly shit, but they did emphasize conservation of momentum. They did do the Newton's laws, the second and third laws, which are pretty much clearly stating that you must conserve momentum laws, and you're perverting all of that logic and sitting there and saying somehow the gun, I fire the gun, the bullet comes out with 2,000 joules of energy, the gun recoil has 2 joules, and you're saying that's conservation of energy, when clearly it's not. Clearly it's not obedient to the third law. So you people are just so full of crap and shit. I can't treat you as anything but dishonest. Because how do you can't counter any of my arguments. You won't counter any of what I just said. You won't explain how it's consistent with Newton's third law that you made 2,000 joules go one way and only 2 joules go the other way. You won't explain how that's at all consistent with any notion of conservation of energy. All right. So you're just dishonest. Fact.